So the methods we're going to use in this course to solve systems of equations are first, substitution, second, elimination, and third, graphing. Graphing is the least accurate of the three usually, but the reason we do the graphing is just so that you can get a physical feeling for what's going on when you're solving these systems. That's what it's for. So method one, substitution. So first you solve for one variable in one equation. So you pick one of the equations, solve for one of the variables, and then you substitute. Using that equation, you substitute into the other equation or equations. Could be more than one equation. Then you solve the resulting equations for remaining variables. And you may have to repeat A and B again if there's like 3 variables or 4 variables, etc. But then after you're done, after you get it down to one variable in one equation, then you solve that for the remaining variable. When you do that, if you get a value for the variable, then you plug it into any of the other equations and then solve those. That's called back substitution. Solve for the second coordinate. By which I meant the other coordinate, not necessarily like the y coordinate, but the other coordinate. 2, if you get 0, 0, 0 equals 0, 1 equals 1, etc. from C, then the equations are dependent, which means you're going to have infinitely many solutions. And if you're doing 2 equations with 2 unknowns, they'll be the form of this form, curly bracket, parenthesis, x, comma, f of x, close parenthesis, such that x is in the real numbers. Okay, 3, if you get 0 equals 1 or 2 equals 5, etc., then there's no solution. Because those are false statements. 0 equals 1 is a false statement. 2 equals 5 is a false statement. So the idea is you start by assuming there's a solution and then find it. Well, if you start by assuming there's a solution and you end up getting 0 equals 1, we call that a contradiction, because 0 is not 1, and therefore the initial assumption that there was a solution is incorrect.